Hello everyone. So let's see. I'm trying to make a video on 4.3ab. So we in this section we introduce the logarithmic function, and if you recall in the 4.1 and 4.2 we introduced the exponential function, and we looked at how to graph the exponential function, what is the domain of the exponential function, the range of the exponential function, and also the asymptote. So exponential function has a horizontal asymptote. In the basic case, when the exponential function looks like f of x is equal to a to the x, so this is an exponential function, and so there are conditions on a. So if a has to be greater than 0, so this is the condition, and a cannot be 1. Okay, so in other words, we see that a is kind of, if we divide the number line into two regions starting at 0, then there is the 1 here. So we start here, skip this, everything else, a can take the value. So when a is between 0 and 1, the shape of the graph looks like this, and if a is greater than 1, then the shape looks like this. But if you notice, in both cases, when we apply the horizontal line test, the function is 1 to 1. So when a function is 1 to 1, we can find the inverse of the function. So here now we define the inverse of this function as the logarithmic function. But the logarithmic function is defined as this. I mean, it is written like this, and we read it log base a of x is equal to y, and this symbol means if and only if. Means is this goes both ways. If the left hand side is true, we can write the right hand side, and if right hand side is given, we can write the left hand side. So this is going to happen only when we have a raised to the power y. So notice here, this is the a, this is the y. So a raised to y equals x. Here is the x. So this is how these two functions are related. So if this is the exponential function, and this is the logarithmic function. So log base a of x is the exponent. So this is what you can notice. Log base a of x is the exponent that to which a must be raised to give us x. Okay, so as I just mentioned, this is called the exponential form, and the other one is called the logarithmic form. So this is the logarithmic form, this is the exponential form, and we should be able to convert back and forth pretty easily, should be. So these two forms are equivalent, and if one is true, then the other is true. And so let's practice some conversions. So here, example, this is done for you. So the first row is the logarithmic form, and the second row is the exponential form of the same expression. So this is the logarithmic form. How do I know it is logarithmic? Because I see the letters log. So we abbreviate the logarithmic as log, and this is log base 2 of 8 is equal to 3. So how do you convert it to exponential form? You start with the base. So here the base is 2. So 2 raised to the power of 3 is equal to 8. So this is the kind of the path you should, or the pattern you should learn. So 2 to the third is equal to 8. And next one, log base 10 of 100,000 is equal to 5. So you can exponential form will be 10 raised to 5 is equal to 100,000, which is true. Similarly, next one is log base 2 of 1/8 is equal to -3. So it will be 2, which is the base, raised to the power -3. So 2 raised to -3 equals 1/8. Okay, here the base is 1/3. So we have 1/3 raised to -2 is equal to 9. Okay. So again, the statement that we had before, that log of log base a of x is actually the exponent. So for example, if I have the exponent in the exponential form, the exponent is 3 here. So in a log base 10 of x is 3. But notice, when we have the base is 10, we do not, like this is a common thing not to put the 10 there. This is like a universal statement, or universally true or accepted. So instead of log base 10 of x, we just say log of x. So if you notice on your calculator also, you have the button log. That means the base is 10. So now next example. So you should try. So this is saying log base 3 of 81 is equal to 4. So following the example up there, you can see I have shown you this. Okay, now even if we have variables or expressions, we keep them as they are. Now notice here in the last one, there is no base given. No base given means the base is 10. So this is called, when the base is 10, the logarithm is called the common logarithm. There is another special logarithm which is called the natural logarithm. And this is when we have the base is equal to e. So what is e? Remember, e is an irrational number, and e is approximately, the value of e is 2.718, or it's again up to you, like how many digits you need. So now if I have ln of x is equal to 5, what it means is that e to the 5 is equal to x. So the base here is e. So you in your head, you have to treat it like log base e of x is equal to 5. So now you can use the same trick. E to the 5 equals x. Same thing here. Ln of 2x minus 1. Now look here, 2x minus 1 is in parentheses, so it is together. So which means e raised to the power 4 is equal to 2x minus 1. So the next one is express each equation in logarithmic form. So you have the exponential form, and we have to convert it to a logarithmic form. So remember, the log is equal to the log of the number will be equal to the exponent. So log base, so I start with the exponent. I say 3, which is the exponent, is equal to, and we know that the base is 10, so 3 is equal to log base 10 of 1000, but because for the base 10 we don't write it, so it's like 3 is equal to log of 1000. Then next one, again power or exponent, 1/2 equals log base 81 of 9, and so on. You should be able to see this. Okay, now there are some properties of logarithmic functions I have given here. first one is saying log base a of 1 is equal to 0. What this means is no matter what the base is, so whatever the a is, as long as a is within that those limits or within that range that we specified in the beginning, that it is not negative, it is not 0, it is not 1. So you can have any base here. If you are taking the logarithm of 1, the answer will always be 0. For example, that's what is in the next example. So log base 4 of 1 is 0. Log base 3 half of 1 is 0. Log of 1, 0. So this, all of these will be 0 because here you see the logarithm of 1. If you notice in the first row, so all of these will be 0. Because no matter what the base is, if you are taking the logarithm of 1, the answer is 0. The next property is log base a of a is 1. So in other words, if you are taking the logarithm of a quantity which is the same as the base, then answer is 1. So looking at the second row of the example 4, log base 2 of 2, answer is 1. Log base 4 of 4, answer is 1. Log base 1/2 of 1/2, answer is 1. So guess what? What will be the next thing? Log 10. So what is the base here? The base is 10. So this can be written as or understood as log base 10 of 10, which will be 1. The next is ln of e. Well, ln of e means log base e of e. So the same thing, so answer is 1. Next one, you see log base 3.1/2, but 3.12 of 3.12, so it will be 1. So if the base and the number whose log you are taking is same, then you get the 1 as your answer. Okay, looking at the third property of the logarithms. So this says if we take the log base a of a raised to x. So this, if you notice, this is slight modification of the property number 2. So if I remove the x from the top here, then the property becomes, or if I put in place of x I have 1, so then it becomes the same as property 2. But now I have x here, so this is saying that whenever you have this situation, log base a of a raised to x, then answer will be just x. So what you have to notice again is that these two numbers are same. So looking at the third row here, so what I'm going to try to do is write the number here as some power of the base. So what is our base here in this example? 6. So 216 I know is 6 cube. So I can write it as log base 6 of 6 cube and apply that property, and it gives me the answer 3. Okay, same next one, log base 49 of 7. Now we know that 49 is 7 square, but remember we are trying to write the number as a power of the base, not the base as a power of the number. So I'm trying to write this number as the power, some power of the base. So base is 49. So when we take the square root of 49, we get 7. So which means 7 can be written as 49 raised to 1/2. So now applying the property, we get 1/2. Okay, next one. So we have base is 4. So we have to think about how can I write square root of 2 as some power of 4. Now we know that 2 is actually square root of 4, okay, and there is already a square root there. So what I can rewrite it, square root or log base 4 of square root of, so we have square root of 2, but 2 is square root of 4. So square root of square root of 4, which means 4 raised to 1/2 raised to 1/2, which will give me 4 raised to 1/4. So you guys should be able to try that next few. So notice here, this is going to give you -6, half, and so on. So you should practice these problems so that you get used to this conversion. Last property here, a raised to log base a of x. So a raised to log a base a. So base here is the same as the base here, because we are raising it to some exponent. So we get back our x. If you try to convert it into logarithmic form, we are trying to look for what should be the exponent of a, so that we get this. So we know that the exponent should be log of x base a. So looking at this last line here, so when this number and this number are same, this is what we get. Now notice again, so this number and the base here same, so answer will be 87. Next one, e raised to ln of 8. So e raised to ln of 8. ln of 8 means log base e of 8. So base is same, so we get 8. So this is, again, we'll get 4. Now the next two are slightly different. We need some properties of exponents. If you recall, if I have x raised to m times x raised to n, we can write it as x to the m plus n. So now if I have, for example, a raised to 3 plus 7, yes, I can write it as a raised to 10, but I can also write it as a raised to the 3 times a raised to 7. So that's what I'm doing here, because this is a plus sign in the power. So we can write it as a raised to ln of 2 times e raised to ln of 2. Now from here we get 2 by the property number 3. And then we get 3 from here. So 2 times 3, answer is 6. So this can be done in 2 ways. The last one. So I have shown you here, I split, because it says e to the 2 ln of 3. So I can write 2 ln of 3, I can write as ln of 3 plus ln of 3. There is a property of logarithms that you will learn later, which will show you that this can be done in some other way as well. But for now, this is very similar to the previous example. So you should be able to see that. Now the next examples are actually the types of problem which actually come in the exams. But at this moment, we cannot do them. We need to learn those properties of or the laws of logarithms in order to be able to do these. So we will learn those laws in section 4.4. Okay, so last example here, it says use the definition of the logarithmic function to find the value of x. Do not set up an equation to solve this. Try to think through the answer. So basically what it's saying is, like, you may write something here. So for example, you can say, well, what is this asking? We have to find x, but if you think, this is saying 5 raised to the 3 is equal to, because your equation will be 5 to the 3 equals x. So 5 raised to the power, what is 5 raised to the power 3? So you know this is 125. Okay, next one. So we are trying to find x. So in the second one,
I don't know that one.
In the second one, x raised to the power 2 equals 25. So x raised to the power 2 equals 25. So what should be the x? Now remember, x could be positive or negative 5, but remember this is the base and the base can never be negative. So x is 5. Next one now, it's saying 3 raised to x is equal to 243. So it means what is the power to which 3 should be raised in order to get that 243. Now in one of the previous examples, if you scroll up, we saw 3 raised to the power 4 is 81. So we try what will we get if we find 3 to the 5th. This will mean 81 into 3, which gives us 243. So which is giving us that x is 5. Okay. So the next one, again, x to the 1/2 power equals 6. So what is x? So that when we take 1/2 power, remember 1/2 power means when we take the square root, we should get 6. So this tells us that x is 36. So this is how we should be able to get these values. So now you should be able to do the homeworks 4.3a and 4.3b if you have not done them yet.